Okay, welcome to Chemistry in the AM. I'm recording. Thank you. So we're looking at pH and pOH. No need to write down these formulas. They're all on your handout set. And this handout set, you're going to have these formulas for any test in my class. Okay? You'll notice that you use the log button. This does not require you to understand logs, but I just want to do a review, and if it's witchcraft, if you press the button, fine, but if not, you kind of understand things a little better if you've done logs before. I forget, foundations math, do you do logs at all?
Yeah.
Yeah, okay. Now, here's the whole thing. Log button on your calculator, they don't write it down, but it's log base 10. So it means if I say this, and I'm going to erase this so you don't have to take this as notes. I want you to just watch. If I say what's the log of 100, you're saying to yourself, 10 to the power of what gives me 100? And you'd say 10 to the 10 squared, 10. So this is asking for the exponent. It's even easier, and I'm just doing this as a review of what logs mean. If I say the log of 10 squared, well, this means 10 to the what gives me 10 to the 2. It is just a trivial question. It is 2, right? Same one. Log of what gives me 100. Okay. Because we're going to be using negative exponents. Okay, and this is where I'm just connecting this to stuff you've seen before. The log of 10 to the minus 3. What's the answer here? Shouldn't need a calculator. This is asking 10 to the what gives me 10 to the negative 3. The exponent is negative 3. Now, here is the formula that we're looking at. You notice that the pH formula has this negative sign in front of the log. Here's why. If I put this negative sign here, the negative log, all that does is gets rid of the sign. This is where the pH scale comes from. pH calculations, these negative logs. They're just finding exponents, except you're going to have pHs like 3.5. This is where it might be like, I don't understand that, because I understand log if you do it 100 or 1,000, 3, and so on. Believe it or not, decimals do have meaning in exponents. So, for example, the decimal exponent 0.5, 1/2. What does that mean? Square root. So, if I said what's 25 to the 1/2, 25 to the decimal 5, I hope you'd say 5, square root of 25. Okay. All I'm saying is that these have meaning. So, if I said, and I'll erase this first. Get out your calculators, everybody, because I want you to play around with this for a second. All I'm trying to say is that the decimals actually do have meaning, and I'm going to use 3.5. It means it involves a square root. It's 7/2, so it'd be the square root of this 10, and then to the power of 7 is what that means. You don't have to understand. In your calculator, to enter this, and this is not notes, you're just playing with your calculator. Usually it's your, I'm going to just write down what button it is. Second function, usually log. Is your second function log actually 10 to the x? And never use that percentage notation because it leads to mistakes, but you will use it for this kind of stuff. Good. Second function log 3.5. Because That's how you enter it. You know what it is? Three. 362.2766. Okay. That's a distance. Okay, I knew it should be in the thousands. Just because it's above 10 to the 3, which is the thousand. Anyways. This is what this means. Now, here's what I want you to do now on your calculator is what is the log of 3162.27766? It should be 3.5, but just it might be rounded a bit though because it's 3.5. You guys see how this is a big circle? Pentata and log they undo each other. They're inverse operations. And that's it for my math lesson, because this isn't a math class, but we got to use log. If this doesn't understand, if these are just buttons you press on a calculator, that's fine. You can still do this. But if you have a bit of an understanding and a connection, it sometimes helps. Now chemistry. That was math. This is going to be chemistry. What is the pH of a solution? You guys write this down. This is the start of your notes. pH. So in your notes, you're going to make some notes. This isn't the hand. Maybe use this type, pH and pO. And then only write down the example question, because the formulas are all in your, well, you know. This is where pH comes. What's the pH of a solution with hydronium ion equals 3.2 10 to the minus 8 moles per liter? Yes. And then what is the pOH? Is the second part of this question. I'll talk to you about pOH now. pH, at least we've heard of it. I don't think you've heard of pH. Don't expect it. Okay. All right. We're going to just practice using this form. Okay. The pH is that, I put a green thing there. pH is this one. Negative log concentration of hydronium ion. By the way, anytime you see hydronium ion concentration, it's the same as the H plus or the proton concentration. Hydrogen ion. I know in university and if you take chemistry, you'll more likely see H plus concentration all the time. I'm driving home this idea of conjugates and stuff like this. So next year you'll see H plus for most people. pH means puissance de hydrogen, it's French, I don't know. Essence of hydrogen or something. Some kind of mess. Puissance de hydrogen. Puissance. I think it means puissance. I don't know. I'm not. Okay. Something French. Essence of hydrogen is a measurement of hydrogen in a log scale. And I won't get into logarithmic scales too much, but they jump rapidly. Okay, anyways. We're going to take it and we're going to use it, pH. The negative log of 3.2 times 10 to the minus 8. Don't worry about units when you get this. But basically, you're going to place your negative sign, or if you don't, you just know to take the negative off. 3.2 10, and you're going to use the EE or EXP button to do 10 to the negative 8. Do not use the second function log to do scientific notation. The EXP button, right? Or whatever your brand calculator has. I'll wait for a second. 7. You're not using the EXP button. Okay, we'll get people. Now, I'm going to tell you this real quickly, too. It is 7.49. Here's two things. I'm not marking for sig figs, but here's how sig figs work if you're going into university with pH, because it's a log thing. The front number doesn't count as a sig fig, and I'm not getting into the math. If you have 2 digits going in, you keep 2 decimals. That's one. How do you know your 7.49 is reasonable? Just take a look at what the exponent is. If it's 10 to the minus 8, you know it's going to be, if it was 1 times 10 to the minus 8, it would have been just 8. So when it's something like 6.7 times 10 to the minus 8, 3.2 times 10 to the minus 8, etc., you know, it's just a little under. So it's like, it'll be 8? No, it'll be a little bit under, 7-ish. Okay? That's how you can estimate, so if you get 6. Now, I'll stop the video and just help people with their calculators if they need. What is the POH? You'll never hear about POH outside of the chemistry classroom, but it's a really handy thing, mainly for calculations. I've never heard of anyone in practical applications using POH, but quite simple. The log scale goes from 0 to 14, right? So if the pH is 10, the POH is 4. They add to 14. And this, the reason why is because the KW of water is 10 to the minus 14. That's why, or the, anyways, I won't get into it. It's actually the neutral water, the concentration of hydronium ion in it is 10 to the minus 7. That's why it's the middle. Anyways, back to this. POH. I'm going to write it out explicitly. pH plus POH equals 14. So I think you can see this is a simple formula. POH, in this case, is 14 minus the other answer, minus the pH. Right? I'll put that 7.49. I'll circle this answer here because that was the first thing I did. POH. You could even do this in head, 6.51. Okay. Now, we have something that describes POH. Now, the pH scale, we talked about it a little bit. 7 is neutral. Smaller than 7, so 3, that's acidic. Oh, that's just a pen fragment. It's 14. There we go. Okay. The POH scale would be the exact reverse. Smaller POH, POH of 3 would be basic. POH of 9, higher than 7, POH is acidic. Nobody uses it other than doing calculations, and here's the reason why. From these, I should be able to get, there's now more than one way to calculate hydronium ion concentration and hydroxide. If I use POH, I can get the hydroxide concentration this way. I could just go 10 to the negative 6.51. I get the hydroxide concentration. Or I could do it the way we were doing it before, where I take this and go, hydroxide is equal to 1 times 10 to the minus 14, divided by 3.2, 10 to the minus 8. Sometimes due to rounding, it gets slightly different answers, like 0.03, 0.07. But, I mean, not that much. But, it's another shortcut. Anyways. So what I gave you was a bunch of questions. I'm going to get you to practice going back and forth, and I'll do one or two of these. Now, you have to do every one of these. I starred a few of them. So maybe just put stars. These are the ones you should try. Just randomly, I kind of do. Well, mine are bold when I handed them out. Okay. Are they the same ones that? I don't care which ones they're. Okay. As long as you do a handful. Pick one of these, though, for me, and I'll go through it with you. I see last year they asked me to find calcium hydroxide. Pick something. I don't care what on this top. Maybe something with the decimal. Tomatoes. Is that a good one?
Yeah.
That's one I have to do. Okay. So I just wrote down the formulas from the first page. These are pHs that are given. So I've made, did I give headings on yours? No. But you're asked to find the list, find your H3O, so the hydronium ion concentration and the hydroxide concentration. To go in between them, it's probably easier to just do POH, even though you're not explicitly asked for it. Right? Now, these are pHs that are given. Tomatoes 4.5, so there's a little bit of acidic. Okay. I'm going to try to keep the same color scheme. H3O. So, if I want to find H3O, and I'm going to use this, pretend I have a column, I've got to use that formula that is, well, what is it? From the formula sheet. H3O given pH, what do you use? 10 to. Here's what I'm going to type in. 10 to the minus, or 3. 10 to the minus 4.5. That's the second function. So I'm going to just jot that in. I guess I'll put down H3O there. I'm putting the heading down. You put this at the top of the page, so you know. But everything underneath here is easy. And I just use the second function of my calculator with the log. I happen to have done it. So verify answers. It is what? Big M for both of these. Now, you have to write down, because this is going to be repetitive calculations. All of these, it'll be like for vinegar, 10 to the negative 2.2. Apples, 10 to the negative 3. 10 to the negative 4. 10 to the negative 4.5. 10 to the negative 6. I don't think you need to show your work rates. If you just do them all as a column straight underneath, maybe grade at the top, 10 to the negative pH. And that's what you use to do all of these calculations. I just want you to get nifty with these numbers. Okay? Now, what I'm saying is that this is just fine. Oh, right. So the POH, I suggested you invent a column called POH. It's going to make your OH, hydroxide, easier to find. So hydroxide, POH, 14 minus the pH. So in this case, 14 minus 4.5, right? You can do it without a calculator. Go figure. 9.5. Everybody understand where you're coming up with that one? So invent a column called POH 9.5. Because I'm only going to write down the answer, but what I'm going to type in my calculator for the hydroxide is 10 to the negative p over. So I'm going to put in my calculator 10 to the negative 9.5 second function log. 14 minus the pH value of 4.
Oh.
That is an easy calculation. And then, what was it? 3.2. It happens by coincidence. This does not usually happen. 3.2 times 10 to the minus 10. Science appreciates. It's a coincidence. Most of them do not have the same front number. Okay? Most of them, I don't think any of the others. Either, oh, there's somewhere here. One. Okay. Other than one. That doesn't happen too often. Okay? So, try the others. This is a shortcut now for, I'd say it's an easier way to go from H0 to OH data. On the back side, you'll see a few questions to try too. Okay? Do the chart and then do the back side. That's your homework today. For the video, you're working at home, I'm going to just display the answers slowly, and then I'll shut the video off. And, like, I have the answers, every one of them. I'm going to scroll, we'll leave it for not even 5 seconds. Pause if you need these answers to check. You need these answers to check, you're working at home. Last, the flip side of the page, if you need the answers, check. Then this side of the page, you need the answers. There you go. Oh, there's more to this one. It's a long. Fine. Okay, I'm going to stop the video. I help you guys to